Welcome to the Network Plus Prepcast, your dedicated audio companion for mastering every objective on the CompTIA Network Plus certification exam. This series is produced by baremetalcyber.com. Cloud connectivity, VPN, and private links introduces the essential technologies used to link on-premises infrastructure to cloud environments securely and reliably. Whether a business is adopting a hybrid cloud model or running multi-coded workloads, it must use connectivity methods that support data integrity, low latency, and scalability. This episode explains the two dominant options: virtual private networks or VPNs and private cloud links. Understanding how each works and when to use them is critical for any organization that depends on cloud-based services for operations, collaboration, or application hosting. The Network Plus exam includes cloud connectivity topics in its WAN, VPN, and cloud service sections. You may be asked to identify the proper connection method for a given scenario, select secure tunneling protocols, or evaluate the trade-offs between internet-based and private access. Scenario-based questions often require you to recognize the best way to ensure secure communication between a corporate network and cloud provider. Familiarity with connection types, device placement, and protocol use is essential for making informed choices both on the exam and in real-world deployment planning. A site-to-site VPN is one of the most common ways to connect a company's internal network to a cloud environment. This type of connection uses Internet Protocol Security, or IPsec, to build encrypted tunnels between devices. These tunnels secure the communication path between the data center and the cloud, protecting traffic as it traverses the public internet. The VPN tunnel typically terminates on a firewall, router, or a virtual gateway provided by the cloud service, forming a secure bridge that allows internal resources to interact with cloud-based systems. Remote access VPNs are designed for individual users who need to connect securely to cloud-hosted applications or infrastructure from outside the organization. These VPNs are usually client-based, requiring software on the user's laptop or mobile device. Authentication is often enforced with multi-factor methods to prevent unauthorized access. This setup allows employees, contractors, or partners to reach internal services hosted in the cloud without opening wide access to the entire network. The encryption provided by these tunnels keeps data secure over untrusted networks like public Wi-Fi. Many cloud providers offer their own VPN gateway services to simplify setup and ensure compatibility. Examples include AWS VPN, Azure VPN Gateway, and Google Cloud VPN. These services provide pre-configured endpoints that allow for quick integration with on-premises hardware. They often support dynamic routing protocols such as Border Gateway Protocol or BGP to simplify route advertisement and failover. Using cloud network VPN gateways removes the need for manual configuration of every device and supports scalable, policy-based access across multiple regions or accounts. Private cloud links are a more advanced option for organizations that require consistent performance and enhanced security. These links use dedicated circuits to connect customer environments directly to cloud providers, bypassing the public internet entirely. This setup avoids the unpredictability of shared internet routes and provides lower latency and higher reliability. Private links are commonly used by enterprises that process large volumes of data, run latency-sensitive applications, or have compliance requirements that prohibit internet-based transmission. And breaking a web linked to your network is considered malware. Examples of private cloud links include AWS Direct Connect, Azure Express Route, and Google Cloud Interconnect. These services allow customers to establish direct, high-speed connections to the cloud provider's backbone network. Connections may be provisioned through a co-location facility or via a dedicated carrier circuit. The configuration includes virtual interfaces, routing definitions, and traffic segregation features that enable fine-grained control over how data flows between local and cloud resources. These connections support encryption, traffic monitoring, and network segmentation strategies required in enterprise deployments. The benefits of private connectivity are clear for organizations that prioritize predictable performance, security, and control. Dedicated bandwidth reduces the chance of congestion, especially during peak internet usage times, Latency is more consistent, which improves application responsiveness and user experience. Security is enhanced because the traffic never traverses the public internet, lowering exposure to potential attacks or unauthorized inspection. These characteristics make private links attractive for organizations with critical infrastructure in the cloud. When deciding between a VPN and a private link, cost becomes a major factor. VPNs operate over existing internet connections and are relatively inexpensive to deploy and scale. They are well suited for small to medium-sized businesses or for use cases that do not require high throughput. In contrast, private links require provisioning carrier-grade circuits, often with monthly costs based on bandwidth tiers. They also demand more complex setup and coordination. Budget constraints, usage patterns, and performance needs all influence which method is appropriate. Redundancy is essential in cloud connectivity designs. Whether using VPNs or private links, businesses should establish failover paths to maintain access if a connection drops. This might include setting up secondary tunnels, using dual circuits, or building high-availability clusters at both ends of the connection. Routing protocols like BGP allow for dynamic rerouting based on path availability, helping the system recover automatically from outages. Monitoring and alerting tools should be configured to notify teams of degraded links or performance thresholds being crossed. Hybrid cloud environments rely on these connection methods to bridge internal infrastructure with cloud-based services. A hybrid setup combines traditional data center assets with virtual machines, databases, or applications hosted in a cloud provider. Site-to-site VPNs or private links allow these disparate components to interact as if they were on the same internal network. This arrangement supports flexible workload placement, centralized management, and disaster recovery architectures, all of which are common on the Network Plus exam. For more cyber content and books, please check out cyberauthor.me. Also, there are other podcasts on cybersecurity and more at baremetalcyber.com. Dynamic routing is a key component of both VPN and private cloud link configurations. Border Gateway Protocol, or BGP, is often used to manage routing between on-premises environments and cloud providers. By allowing route advertisements to change automatically based on link status or administrative preferences, BGP helps maintain optimal connectivity. If a primary path fails, the backup route becomes active without manual reconfiguration. This ensures that data continues flowing smoothly, even during outages or maintenance events, which is essential for high-availability cloud deployments. Monitoring and troubleshooting are essential for maintaining reliable cloud connections. Most cloud providers offer console-based tools that show real-time link status, latency measurements, and tunnel health indicators. Additionally, traditional tools such as Simple Network Management Protocol, or SNMP, and syslog can be used to gather diagnostic information from firewalls, routers, and gateways. Log entries reveal tunnel establishment attempts, authentication errors, packet loss, and throughput metrics. This visibility helps identify performance issues before they affect user experience or data integrity. Security must be a central focus in any cloud connectivity plan. VPNs rely on IPsec to encrypt traffic between endpoints, ensuring that even if data travels across untrusted networks, it remains unreadable to outsiders. However, even private links benefit from encryption at the application or transport layer using protocols such as TLS. Additional security controls include access control lists, security groups, and firewall rules to restrict traffic based on source, destination, or protocol. These layered defenses help enforce least privileged access and reduce the attack surface of the network. Cloud providers offer vendor-specific gateway features that enhance visibility, automation, and security. For example, AWS Site-to-Site VPN includes CloudWatch metrics for monitoring and can integrate with identity and access management tools. Azure VPN Gateway allows for policy-based routing and supports connections from multiple sites. These gateways often include support for hybrid routing configurations, static and dynamic route controls, and traffic inspection. Understanding the capabilities and limitations of each vendor's offering is critical when designing enterprise-grade connectivity. Multi-crowd environments introduce additional complexity when planning connectivity. Organizations that use services from multiple cloud providers need to establish secure and efficient links between those environments. This may involve configuring VPN meshes, deploying cloud-native routers, or using third-party tools to aggregate routes and apply filters. Traffic between clouds must be segmented, encrypted, and monitored to prevent unauthorized access or data leakage. Proper route filtering and policy enforcement help prevent route conflicts and ensure that only necessary traffic crosses cloud boundaries. Cloud firewall integration is an important consideration when managing traffic between cloud and on-premises systems. Cloud firewalls operate at the edge of the provider's network and allow administrators to define traffic rules for inbound and outbound connections. These rules enforce segmentation and ensure that only authorized applications and services can communicate. Firewalls may also log connections, block suspicious activity, and apply rate limits to prevent abuse. Applying firewall policies early in the deployment process helps maintain security compliance and operational integrity. Accurate documentation and topology mapping are vital in cloud connectivity projects. Visualizing the network with diagrams that include routes, interfaces, tunnel endpoints, and service providers improves team coordination and simplifies troubleshooting. These maps should be updated regularly and included as part of change management procedures. Documentation is often required for internal audits, external compliance reviews, and vendor support interactions. It also helps onboard new team members and ensures that knowledge does not remain siloed with a single administrator. The Network Plus exam includes questions that ask you to distinguish between VPN and private link solutions, identify appropriate protocols and ports, and match specific use cases to the right connectivity option. You may see scenarios that require evaluating performance needs, security requirements, or cost constraints. Being able to differentiate between site-to-site and remote access VPNs, as well as understanding the advantages of dedicated links like AWS Direct Connect or Azure Express Route, will help you answer exam questions confidently and accurately. Cloud connectivity options such as VPNs and private links allow organizations to bridge their local infrastructure with cloud-hosted services securely and efficiently. Each method has trade-offs in terms of cost, complexity, performance, and security. VPNs provide quick, flexible, and low-cost connectivity using the public internet, while private links offer dedicated bandwidth and better control. Choosing the right method depends on the organization's needs and resources. Mastering these concepts is essential for cloud networking success on the exam and in practical deployment. Thank you for listening to this episode of the Network Plus Prepcast, your trusted audio guide to the CompTIA Network Plus certification. This episode was produced by baremetalcyber.com. For more cybersecurity podcasts, books, and resources, visit baremetalcyber.com. Thanks for joining us for this episode of the Bare Metal Cybersecurity Plus podcast. For more episodes, tools, and study support, visit us at baremetalcyber.com. And before you take the test, make sure to check out the practice questions in the book Achieve CompTIA Security Plus SY0-701 Exam Success by Dr. Jason Edwards. They cover every domain and are a powerful way to lock in your knowledge.